In this presentation, we have to talk about types of nuclear reactions. We should know the definition of the term nuclear reaction. Suppose a target is bombarded by an incoming particle of sufficient energy. The character of the target is completely changed because the incoming particle contributes some amount of its energy to the target. Now read out the statement. It's possible to bring about a change in the structure of a nucleus by bombarding it with a fast moving particle. The target's character changes during this process called nuclear reaction. Types of nuclear reactions include elastic scattering, inelastic scattering, disintegration, photodisintegration, stripping and pickup reactions, fission reaction and fusion reactions. Now we have to discuss them one by one. First one is elastic scattering. In the case of elastic scattering, the incoming particle does not transfer any amount of energy to the target. The only change is the deviation in the direction of the incoming particle. Now read out this statement. In this process of elastic scattering, the incident particle strikes the target and leaving without loss of energy, but the direction is tailored. Here A, the incoming particle, X, the target. Once again we are getting X and A. No energy transformation is taken place in this reaction, so that we are calling this reaction as an elastic scattering reaction. The only change is the direction of the incoming particle is tailored. Second one is inelastic scattering. During this process, the incoming particle transforms certain amount of energy to the target. Therefore, the target is promoted to the excited state. We won't expect the target in the excited state for a long run, that is reaching its ground state by the way of emitting a photon of energy h nu. During this process, the incident particle gives the target a significant portion of its energy. After interacting with the incoming particle, the target goes to the excited state and decays to the ground state by radiating surplus energy as a photon. X, the target, A, the incoming particle. After the interaction process, X is reaching its excited state, that is represented by X star. Then the incident particle A comes out of the system with lesser energy. Then X star reaches its ground state by emitting a photon of energy h nu. See this example. Lithium 37, after absorbing a proton, reaches the excited state of lithium 7 with a star. It comes to the ground state once again by emitting a photon of energy h nu. This is an example for inelastic scattering. And the third process is disintegration. The incident particle is absorbed in this process and a different particle is ejected. See here, if the proton is a projectile particle, we can get deuteron, alpha particle and a neutron as an outgoing particle. In this nuclear reaction, the proton is a projectile particle, deuteron is outgoing particle. Here proton is the incoming particle, outgoing particle is alpha particle. Here proton is the incoming particle, neutron is an outgoing particle. So this type of nuclear reactions are coming under category of disintegration. If deuteron is used as a projectile, see here H12 deuteron, it can give alpha particle. Deuteron provides proton, deuteron gives a neutron. Then if you use alpha particle as a projectile particle, you can get photon, proton, like that. If neutron is used as a projectile particle, we can get different particles. Say here energy is liberated in the form of photon. Then neutron provides alpha particle, neutron provides proton, neutron provides two neutrons. The interaction of neutrons with the nuclei may result in the generation of the gamma ray photon, alpha particle, proton and neutron respectively. Next category is photo disintegration. Nuclear reactions caused by high energy radiations are known as photo disintegration. To proceed with photo disintegration, the incident photon's energy must be greater than the binding energy of the particle to be emitted. Suppose the incident photon's energy is lesser than the binding energy of the particle expected, the emission will not be taken place, whereas the excitation of the target to higher energy state is possible. See this H12, after interacting with the photon of appreciable energy, we can have a proton and a neutron. This is deuterium. Deuterium, after absorbing the sufficient energy photon, provides a proton and a neutron. If the energy of the incoming photon is not sufficient to remove a particle from the system, to remove a nucleon from the system, the excitation of the target alone is taken place. See this example. Krypton 3683, after absorbing a photon of low energy, reaches its excited state, then comes to the ground state by emitting a photon. If the energy is insufficient to remove a neutron, the nucleus may enter one of its excited states and later emit excess energy as radiation. This is called a photo disintegration process. So in the photo disintegration, if the energy of the photon is sufficient to remove a neutron from a target, the reaction is taken place. If the energy of the photon is insufficient to remove a neutron from the target is promoted to its excited state. Next case is stripping and pickup reactions. In a stripping reaction, the target captures one or more nucleons from the projectile while the remainder continues. See, this is a deuteron which consists of a proton and a neutron. When a deuteron interacts with copper 63, copper 64 is produced and a proton is coming out of the system. Here, a neutron is extracted from the deuteron by the copper. So that we are calling this reaction as a stripping reaction. In a stripping reaction, the target captures one or more nucleons from the projectile while the remainder continues. Here deuteron is a target, deuteron is a projectile, copper is the target. The copper absorbs one neutron from the deuteron and the remaining proton is coming out of the system because a deuteron consists of a proton and a neutron. In a pickup reaction, an incident particle collides with the target nucleus and immediately pulls out one of the nucleons from the target nucleus. The inverse process of stripping reaction is pickup reaction. Anyway, the stripping and pickup reactions do not proceed through the formation of compound nucleus. This is familiar one, fission reaction. In fission reactions, the target nucleus, after interacting with the projectile, splits mainly into two lighter nuclei of comparable mass, and at the same time it emits a few neutrons. Uranium-235, after bombarding with the neutron, provides barium and krypton with the emission of 3 neutrons and a huge amount of energy. Then fusion process. In the case of fusion reaction, lighter elements combine to give a new element along with the release of large amount of energy. Here 4 protons combine to form helium-24 with the emission of 2 positrons and 2 neutrino and 2 gamma radiation with the emission of enormous amount of energy. So that's all about the types of nuclear reaction.